Welcome to KU band class. Today we shall discuss an interesting and important topic, that is traction motors. As an electrical student, we have to know in details about traction motors. So before going to our topic, so here is a question for you. Let us say slide. This high speed train is a questioning to you. Please answer, think it and give the answer at last. Now coming to our topic. So that is traction motors. In traction motors, first of all, so motor characteristics. Second one, suitability of motors for traction, and third one, control of traction motors by auto transformer. In this class, so we will discuss in details about these 3 points. Coming to first, that is the motor characteristics. So desirable characteristics of traction motors. The train is or traction motor is expected to have both electrical and mechanical characteristics. In previous classes, we have seen a different type of motors based on principle and constructions, and we have studied electrical and mechanical characteristics in general point of view. Here, traction motors refer to traction, we have to study. So what are the electrical characteristics and mechanical characteristics? Let us go one by one. What are the requirement of electrical characteristics? So electrical characteristics. Let us assume this is the motor for traction. It should have, first of all, high starting torque. Second one, easy speed control methods. And third one, it should have the dynamic and regenerative braking facility. And the traction motor speed will fall with increased load. And so we design motor should be capable to bear voltage fluctuations, and the motor capable to bear the overload capacity, and motor is capable to parallel operation. It can withstand temporary interruption of supply, and final characteristics is the overall efficiency should be very high. These are the 9 characteristics required for traction. So let us see one by one in details. High starting torque. So you are the well familiar with speed time characteristics. So from 0 to T1, we require the high tractive effort for acceleration of train to pick up speed up to required speed. From T to T3, even it is running at high speed, it takes a constant power from overhead line, but it so required tractive effort is small, only to overcome for the tag resistance and the gravity component. So if you have designed a traction motor, it should give high starting torque at starting. So, that is a main requirement in traction motor. And second characteristic, that is the easy speed control. So, let us see here. So, S1, S2 and S3 are assumed as a railway stations. The train subjected to frequent start and stop. Hence, we required easy and simple speed control method. The speed should controlled mainly where the track repair work is going on, and so some where the train may be very curved. Let us say in figure. So, you can see, so this is a curved position. In this case, the motor speed should be reduced to low value. Otherwise, what happen, you know. So, coming to next characteristics, that is dynamic or regenerative braking. Here also, so we are expected the train should stop, so exit on platform in the station itself. Hence, we require so good the dynamic and regenerative braking facility. And coming to next, so easy and simple methods of dynamic and regenerative braking is required for if you manufacture the motor for traction. Let us go to next characteristic. Speed should fall with increased load. If you design the traction motor, it should have the following characteristics, that is a speed. So, you can see the speed is the torque characteristics. At starting, the torque developed is more and the speed is less. When there is a load on increased on traction motor, the speed will fall. So, this is a very good for characteristics, so avoids the overloading of motors. So, coming to next characteristics, capacity to withstand voltage fluctuations. You can see here the S1, S2, S3, S4 and S5 are the some railway stations. We required every station start and stop, and we know that the starting torque is required more at start and it draws a more starting current. Due to drawing at frequent start and stop, it may draw the high current. Due to this one, there is a possibility of voltage fluctuations in overhead lines. Even then, our motor withstand these voltage fluctuations. That means the wiring should be high quality of the insulation. And so, due to frequent start and stop, the motors will subjected to rapid voltage fluctuations. Even these fluctuations can withstand our motor. Let us go to next characteristics, that is overload capacity. Our motor should design such that it can bear the overload. For example, so motor, the train is moving at a path. So, any one station there is a possibility of heavy passengers. Even then it can bear easily, such that we have to design our traction motor. The motor should be able to bear the overload conditions. It is a required characteristics. And coming to other characteristics, so parallel operation. We know that no single motor is able to bear total locomotive weight. Hence, we require the more than one traction motors are required. And traction motors for parallel operation, more or less all motors having similar the speed, torque and current torque characteristics. If you are having these characteristics, the load shared by each motor is more or less equal. And if you design the motor, it should be capable in parallel operation. And next characteristics is the temporary interruption of supply. So, here the temporary up supply to the motors occurs due to crossovers and when it reaches section insulators. motor should be capable of avoiding heavy inrush current. We know that the interruption of supply to the motors may be occurred when the train reached or crossed the crossovers and section insulators. So, you know the section insulators. For example, if you are taking the one line from Hyderabad to Warangal, from Gatkesar one substation feeding the supply to the overhead line, it can up to some kilometers. Next, so Raghunathalli another substation is feeding the remaining portion up to the Warangal. So, before this supply and this supply, so there will be a section insulator. If any interruption of supply, even then it can withstand. What happens if the interruption takes place suddenly to the traction motors? We know that, so there is a possibility of high inrush current enter into the motor. If enter the high inrush current into the motor, there may be a possibility of the damage. So, we have to design our traction motor such that it can bear, it can withstand this high rush current. And coming to last characteristics, that is overall efficiency. That means our motor should have less minimum losses. The losses you know, that is core losses or mechanical losses or copper losses, such that you have designed. So, our motor is number 1. So, these are the 9 characteristics for the traction motors required. Even then, if satisfying our motor these 9 characteristics, so it should satisfy mechanical characteristics also. What are the mechanical characteristics? Let us see. So, same motor is satisfied all electrical characteristics. Now, so it should satisfy these characteristics. The motor should be robust. The motor should be designed robust. It can withstand any mechanical vibrations, because the train is moving one place to another place at different speed. There may be possibility of vibrations. Even then, so the motor should be very robust. And coming to second characteristics, the small in size. We know that the space available in locomotive itself is limited and permitted. Hence, we have to design our motor as small as possible. And coming to third characteristics, light in weight. We know that train is moving one place to another place. So, weight is more, gravity is more, there is a disturbance. So, we have to design our traction motor as light as possible, the light in weight. And fourth characteristics, that is a very important, totally enclosed. We know that the traction may be subjected different weather conditions, because the train may be past different states, and different states having the different weather conditions. There may be chances of ingress of dust, dirt particles. Even then, so our motor enclosure should be totally enclosed. These are the 4 mechanical characteristics. So, if you are design traction motor, it should require actually we require these 9 plus 4 requirements. Practically, we have seen the different motors based on principle and constructions, but no one motor is satisfying these all characteristics, but more or less few motors are satisfying few of characteristics. So, in this class, so we shall go, so in this class we will discuss those matters. So, let us go. So, what are the motors? Suitability of motors for traction. Traction motors mainly in DC side and AC side. In AC side or DC side, few motors are very efficient. In DC side, you see, so well known motor, that is DC series motor and somewhat is a DC shunt motor, and DC compound motors also used for tramways, not for locomotives. In AC side, so main motor is the AC single phase series motor and AC 3-phase induction motor, repulsion motor and linear motor. These are the motors for traction. In this class, so we shall discuss in details few of the motors. Now, let us go to DC side, DC traction system. Before going to direct to the traction motor, at a glance you can observe the existing DC distribution system. So, you can observe here existing DC system. So, here the power is taken from the EHD substation, that is a 130 kV at power frequency, that is a Indian frequency. Same is given to the power transformer, where the power transformer is connected, so 3-phase open delta or SCAT connection, and step down to 1500 volts or 3000 volts by using step down transformer. We require the DC supply, so we require the rectifiers. The rectifiers may be, so here you can see these rectifiers may be semiconductor rectifiers or rotary converters or mercury arc converters. So, by using these rectifiers, the AC supply, that is a 1.5 to 3 kV, so is converted AC to DC, and one is a positive, another is a negative. So, negative is given to the ground and positive is given to the overhead transmission line. Here is the traction line. In train, we are using the DC motors. It takes the supply through the pantograph, through the control circuit. And so, due to the low voltage, we step down voltage from 132 to 1.5 volts or 3000 volts. Due to the low voltage, the current value increases due to the 4 voltage regulations. Hence, we require to feed the DC supply to the overhead transmission line. So, number of feeding stations are required. In case of suburban, so 3 to 5 kilometers space for the feeding stations. So, you can see here. So, here is a one feeding substation, here is a another feeding substation for the suburban urban lines. For mainline services, it may be increased to 40 to 50 kilometers apart. Now, let us see what are the main merits of a DC system. So, DC distribution system has less capital and maintenance cost, no interference with communication lines. DC train equipment is lighter, that is light in weight, less costly and more efficient. These are the few advantages of DC distribution system. And coming to disadvantages, so due to low DC voltage, system number of substation of AC to DC or more. So, already we have seen, so due to the low voltage, the number of feeding stations are required more. These are the one drawback. And now, let us go to DC motor. It is a very familiar motor. So, you have seen in second year, so principle and constructions, its basic characteristics all. So, at a glance you can see here. So, this is armature and series field and interfolds, and we know that this is electrical characteristics and this is a mechanical characteristics. So, we know that general characteristics of this series motor, it has high starting torque, and this starting torque is depend upon or proportional to the square of the current, and the speed is proportional to the or depend upon the load current. The speed can be varied by using the diverted resistance. So, these are the we known these characteristics of series motor. So, you can see here, so different series motors for traction manufacturing. So, you can see the practical examples how they are manufacturing. So, this is a one type of the series motors, here is the series motors and here is the series motors. You can see the armature size, and next, by using these series motors, we can use these series motors in electrical locomotive as well as in diesel locomotive also. If you are observing, here is a diesel locomotive. In diesel locomotive, the motor runs our DC series generator. DC series generator generates a EMF. That EMF is supplied to the 6 to 7 the remaining DC motors. Hence, it is a very high starting torque. Why should you use this DC series motor in familiar? Because it is satisfying the number of requirements of traction. What are they? So, we can see one by one. Characteristics of series DC series motor. It has high starting torque at low speed and low torque at high speed. Speed, torque and speed current curves of series motor are steep. Due to steep curve, the speed control is very easy and stability. Commutation property is very good. It can withstand even under heavy load conditions. Current drawn is less compared to shunt motor and 3-phase induction motors. Regenerative braking is possible with special arrangements. High rates of acceleration and retardation are possible due to low weight and high starting torque. For acceleration, we know that we require the high starting torque. For retardation, it should be low weight. Due to having these characteristics, it is best suited for urban and suburban services. So, it has the number of advantages comparing to other motors. Even then, it has some drawbacks. So, what are the drawbacks? You can see here. Due to presence of commutator, there is a restriction of speed, voltage and current. And second one, flashover problem due to high current. These are the few drawbacks. So, let us go to AC system. So, we have seen in DC system. So, what is the DC distribution system existed, and the suitability of traction motor, that is the DC series motor in construction and principle its characteristics. It is a very efficient motor for traction. Now, let us go to the AC side. Before going to the AC side, so at a glance you can see the AC distribution system. So, AC distribution system is similar to the DC system. Here are same the R, Y, B 3 phases taken from APSB people at high voltage. So, 132 kV at Indian frequency, and by using the power transformer step down to 15 kV at Indian frequency. Here is a special arrangement you can see. So, here is a synchronous motor. the output of the transformer is given to the input of synchronous motor. Then, so it is mechanically, the mechanical output is given to the input of single phase alternator. So, mechanically the synchronous motor and the alternator is mechanically coupled. The single phase alternator generates the voltage 15 kV at reduced frequency. So, it may be 16 2/3 or 25 Hz. This reduced frequency and 15 kV voltage is given to the overhead line. From the overhead line, AC motors are taking supply through pantograph and control circuit, and another step down transformer which is located in locomotive itself. And so, you can observe one thing. So, what is the necessary to reduce the frequency from power frequency to the lower frequency? We have some advantages. What are the advantages? You can see here. So, low frequency advantages. Low frequency AC supply is used for improving the commutation property of motor. Second one, improving power factor and efficiency. And third one, less line reactance and low voltage drop. You know here, you know the line reactance, that is a XL. XL means omega L. What is the omega L? That is the 2πfL. F means frequency. Due to the reduction of frequency to the small value, the reactance value decreases. Due to this one, the I into XL, the drop decreases, thereby the voltage regulation improved, and voltage drop is reduced, thereby overall system voltage regulation improved. And fourth one, it is feasible to space the substation 50 to 80 kilometers apart. Same thing you can observe in DC system. Due to the 1500 or 3000 volts, the number of substations required is more. Only the maximum space between the feeding stations, the 30 to 40 kilometers. But here, due to the high voltage, we can feasible to space our feeding substations, so nearly 50 to 80 kilometers apart. That is a very good advantages. And the fifth one, reduces communication line interference. Due to the low frequency, the interference with the communication lines reduces. And coming to next, the merits of AC system. You can see, due to high voltage, the current